Yesterday at 30 UTC, solar observers captured something alarming. Sunspot AR4317, which has been quietly growing on the sun's surface for days. Just did something we rarely see. Its two dark magnetic cores merged into a single unstable gamma-class configuration. And according to astronomers monitoring the region, this sunspot is now a ticking time bomb. Welcome back. For the past week, we've been watching Solar Cycle 25 deliver an unexpected Christmas surprise. Fast solar wind from a massive coronal hole, minor geomagnetic storms, aurora displays across Scandinavia and Canada. But while everyone's been focused on the northern lights, AR4317 has been quietly building energy. And what happened in the last 48 hours changes everything. NASA's Solar Dynamics Observatory, continuously watching the sun in multiple wavelengths, recorded the merger on December 23rd. Two separate magnetic nuclei, each with opposing polarity, collided and fused. The result? A delta-class sunspot with what solar physicists call an unstable gamma magnetic component. Let me translate that. Delta class means the magnetic field lines are twisted, compressed, crisscrossing in ways that shouldn't be stable. Gamma configuration means the polarity gradients are steep, dangerously steep. When you combine those two, you get a magnetic pressure cooker. And the question isn't if it'll release that energy, it's when. Chilean astronomer Patricio León, who photographed AR4317 through his hydrogen alpha light telescope, put it bluntly, this spot has an unstable gamma magnetic component which can produce energetic flares not might produce, can produce, that's the language solar physicists use when they're genuinely concerned. But here's what makes this particular sunspot so interesting: it's not acting alone. Just 2 days ago, on December 21st at 1812 UTC, the neighboring sunspot AR4316 unleashed an M1.3 solar flare moderate class, the strongest eruption we've seen in nearly 2 weeks. That flare raised solar activity levels from low to moderate in a matter of minutes. AR4316 then followed up with 19 C-class flares in the next 24 hours. 19. That's not normal background activity, that's a region under stress, releasing energy and bursts. Now here's the critical part. AR4317 is positioned right next to AR4316, same active region complex, same magnetic environment, and when one sunspot in a complex starts flaring, it often triggers sympathetic flares. In neighboring spots, the magnetic field lines interconnect, energy release in one area destabilizes another. It's like dominoes, but with plasma temperatures exceeding 18 million degrees Fahrenheit. So what happens if AR4317 actually erupts? M-class flares aren't the end of the world, but they're not trivial either. An M-class flare releases as much energy as 10 million hydrogen bombs. That energy travels to Earth in 8 minutes as X-rays and extreme ultraviolet radiation. When it hits our upper atmosphere, it ionizes the ionosphere. Radio signals on the day side of Earth degrade. High frequency communications, aviation, radio, maritime navigation, all disrupted. And if the flare is strong enough, say M5 or above, you get what's called an R2 or R3 radio blackout. Moderate to strong, that means areas larger than Australia lose HF radio contact for 10 to 60 minutes, but there's more. M-class flares often produce coronal mass ejections, CMEs. Those are the ones we really watch. Isn't just radiation traveling at light speed, it's a billion-ton cloud of magnetized plasma traveling at 1,000 to 3,000 kilometers per second. And if AR4317 erupts while it's Earth-facing, which it currently is, that CME could hit us 2 to 3 days later. NOEA Space Weather Prediction Center hasn't issued a warning, yet their current forecast says mainly fair space. Weather expected through Christmas week, but that forecast was issued before. Our 4317 score is merged before the gamma configuration. Formed forecasts are not going to change when conditions change, and right now conditions are changing fast. Here's where it gets interesting. Some solar physicists think we're overdue for a major flare. Solar cycle 25 peaked in October 2024, yes, but the declining phase of a solar cycle often produces the most complex sunspots. Why? Because the sun's global magnetic field is reorganizing. Polar regions are flipping. Old magnetic flux from the previous cycle is still decaying. New magnetic topologies, delta-class spots with gamma configurations, exactly we're seeing with AR 4317, but others argue that December is historically a quieter month for solar activity. The sun follows seasonal patterns even though it's not influenced by Earth seasons. Some statistical analyses show fewer X-class flares in December and January compared to spring and fall. So maybe our 4317 is all bark and no bite. Maybe those twisted magnetic field lines will slowly relax without a major eruption. What do you think? Are we due for a big one, or will AR 4317 fizzle out quietly? Drop your prediction in the comments now. Even if R 4317 does flare, there's a silver lining. We're watching it in real time with instruments our grandparents couldn't have imagined. The Solar Dynamics Observatory captures images every 12 seconds in 10 different wavelengths. The GOES satellites monitor X-ray flux continuously. Ground-based observatories like the one Patricio Leone uses provide complementary data. We have a 24-hour early warning system for radiation storms and an 18 to 72-hour warning for CMEs. Compare that to 1859, the Carrington event, the strongest geomagnetic storm in recorded history. Telegraph operators had no warning, none. The first sign was when their equipment started sparking, catching fire. Aurora appeared as far south as Cuba. If that happened today with our electrical grid, our satellites, our GPS-dependent infrastructure, estimates range from hundreds of billions to trillions in damage. But we're not in 1859 anymore. We have prediction models, response protocols, satellite operators who can put assets in safe mode. We have systems and events like AR 4317, are why those systems exist. So what happens next for the next 48 hours? R 4317 remains Earth-facing. If it's going to erupt, this is the window. After that it rotates toward the sun's western limb and becomes less of a direct threat. Any CME launched from there would likely miss Earth, but for now we watch. Solar physicists around the world are monitoring this spot every hour. Amateur astronomers with solar telescopes are posting updates. The data is flowing, and here's the thing. Maybe R 43117 does nothing. Maybe those twisted magnetic field lines hold for another week until the spot rotates out of view, or maybe, just maybe tonight or tomorrow we see a flash in M5 and M8, maybe even an X-class if the conditions are right. And if that happens 8 minutes later, radio operators will know. 2 days later we'll know if a CME is going to erupt, if it's going to erupt, and then we'll know if a CME is coming. And 3 days later we might see aurora as far south as Virginia or Colorado. That's the game we play with the sun, watching, waiting, predicting, because the sun doesn't care about our schedules. It doesn't care about Christmas or New Year's. It follows its own rules, its own cycles. And right now R 4317 is following the rules of unstable magnetic configurations. Thank you for watching. And if you think AR 4317 is going to surprise us with a major flare, let me know in the comments. Until next time, keep watching the skis.